Welcome everybody to our UCGIS webinar today, March 6th. We're very happy to be joined by Eric Shook and Shaowen Wang. I'll introduce them shortly, who are going to give their talk on the Convergence Curriculum for Geospatial Data Science. We're very happy to have everybody with you, or with us. We're all here together. And we're going to have Shaowen and Eric go through their topics and discussions. Feel free to put in a question into that Q&A box whenever something pops up, and we will be saving plenty of time for Q&A at the end, I'm sure. My name is Forrest Bowlick. I'll be moderating and reading off the questions and whatnot. We're joined today by Eric Shook. Dr. Shook is associate professor, excuse me, Eric, at the University of Minnesota in the Department of Geography, Environment, and Society. And Dr. Shaowen Wang is professor and head of the Department of Geography and Geographic Information Science at the University of Illinois, Urbana-Champaign. As I mentioned, they will be discussing the Convergence Curriculum for Geospatial Data Science. So I will get no more titles wrong and hand it over to them. Thank you both, and looking forward to the presentation.
Well, thank you very much, Forrest, and also thank you, Eric. And my name is Shaowen Wang. As Forrest introduced, we're going to be discussing the Convergence Curriculum for Geospatial Data Science, which is a major initiative of the Institute for Geospatial Understanding through an Integrative Discovery Environment funded by the National Science Foundation. In short, iGuide. I'll give a quick introduction to iGuide, and then I'll hand it over to Eric to do a little bit deep diving into the Convergence Curriculum. All right, Eric, do you see my slide is moving? All right, see nodding. Thank you. Yeah, so a few years ago, exactly, that was 2021, NSF announced 5 national institutes focused on harnessing the data revolution, and one of which is iGuide, with the initial $15 million for 5 years funding. Now we are up running for a year and a few more months. So we have 11 collaborating institutions, including both Eric's, University of Minnesota, and UIUC. That is our leading institution. I'm serving as the director and the principal investigator. You might go to the URL, the link at the top of the slide here to get to know more about the project. So it's i-guide.io. So our vision is digital discovery and innovation through geospatial connections and through harnessing the geospatial data revolution. Our mission is to transform convergence and geospatial sciences for holistic sustainability solutions. So to translate our vision and mission into more easy to understand terms, exactly this tagline we have: map, connect, and discover. And also, if you think of, for instance, the Sustainable Development Goals as the United Nations organize them, it's straightforward to understand. You have to come up with holistic solutions to addressing these goals because a lot of them are highly interdependent with each other. So in iGuide, we have 6 key components. And on the left, you see convergence science catalysts. You could think of this as, for instance, as a connect different domains and disciplines together to respond to major sustainability challenges. And convergence is to connect across different domains. And within iGuide, we have over 12 disciplines represented. And we are pushing the frontiers of geospatial AI and data science, enabled by cyber infrastructure capabilities and services. And we also have ambitious educational workforce development agenda This part is led by Eric Shook, and Convergence Curriculum is a key initiative, as I mentioned. And also we have engagement and partnerships team working very hard to bring a broader community together to solve some of the pressing sustainability challenges. And we also have evaluation knowledge transfer component in the project to make sure what we do here gets evaluated, not only by our project, but also by the broader community, and also make sure the knowledge is accessible broadly to the related stakeholders. So how do we tie this all together? I'm going to walk you through the individual components summarized on this slide. And to start with the convergence science catalyst, our objective is to create the knowledge needed to solve complex problems of resilience and sustainability in a multi-scale and telecoupled context through geospatial data intensive or multi-type, including AI, theory-based and mechanistic analysis and modeling. So just to give you a few quick examples in terms of, for instance, sustainability challenges, one part of the world has some really significant changes today, such as Ukraine war. You would be able to tell other parts of the world getting affected in a cascading fashion. So how do you really represent these interconnected changes? And we have 4 themes within the project so far, and we are open to have more catalysts to expand these themes. But the first one here listed is hydroclimatic extremes and associated vulnerability. So on the right hand, this figure shows, let's say, if you have major precipitation, for instance, currently happening on the West Coast, and that could stress infrastructure like dams, or particularly aging dams. If there might be any failures, this could have cascading effects, possibly leading to floods. And then, of course, that would lead to perhaps disruption of other infrastructure and utilities, and possibly crop production, not necessarily locally, but could be regionally and somewhere else interconnected. So our argument is, with availability of massive geospatial data dynamically coming, we're at the cusp of representing these dynamics and really understanding the changes that are interconnected across multiple geospatial scales over time. And we have the potential to be able to predict the changes going into the future. So this is sort of the major science driver we're going after here. I'm not going to go through the other themes listed on this slide, but you could tell this is not just a local, but regional, yet national, even global interconnections. We're hoping to represent, model, and even predict such changes. So there's a recent article published on Directions magazine. The link is at the bottom of this slide. I would encourage you to read this article. This is a really sort of simple way of expressing what iGuide does in terms of our convergence science, more than just what equations and academic terms we could use to share what we're doing. This is really easy to understand. And geospatial AI and data science here is focused on enabling convergence science, research and education through innovation of geospatial knowledge hypercubes. So what we mean by geospatial knowledge hypercubes is how do we combine a variety of geospatial data with domain-specific models. This is sort of the left and right top of this figure, and translate that into this multi-scale representations, what we term as geospatial synthesis. And how do we also get this transformed into their computational terms, and how do we combine them in a coherent and scientifically rigorous way through computational logic that could take advantage of large-scale computing resources to enable the analytics of massive data, but at the same time supports the integration between data and models. So this whole conceptual framework is what we're setting up. And in order to do this, we need the support from advanced cyber infrastructure team. That's what this team is focused on in terms of integrating distributed geospatial data capabilities and advanced cyber infrastructure to form a composable and open iGuide platform to accelerate scientific workflows and support education workforce development. And that's the part of today we're focusing on. Eric will get us into more details. And of course, as well as broader community engagement that requires advanced cyber infrastructure as well. So on some of these slides, we have our team members featured. I'm not going to have time to introduce each of our team members, but just so that you recognize this is quite a sizable collaboration on our Slack channel, including everyone. I think we have over 100 team members, as I said, from over a dozen disciplines. So, why we need to establish iGuide platform. If you would pursue scientific investigations into the problems I was alluded to earlier, requires the integration of different disciplinary expertise. You would require data from different domains, and they're likely hosted different places. And you need to draw this data together, and then you need to combine them with domain-specific models that might be running also in different computational environments. But from individual scientist perspectives, you don't want to directly deal with these data sources or different models. You would rather want to have a holistic, easy to work with discovery environment, allows you to focus on your science problems and questions. So this platform we're developing exactly serving this purpose, to lower the entry door for scientists to be able to harness massive distributed geospatial data, and at the same time to take advantage of very powerful computational cyber infrastructure resources. And the examples listed here, these cyber infrastructure and data resources are from different communities that cut across social and natural sciences. So it's very difficult, if in many cases nearly impossible, for any scientist to be able to assemble such community-based cyber infrastructure capabilities together to conduct efficient scientific work and discovery workflows. So our focus here is to really free scientists from the nitty-gritty aspect of assembling these capabilities together to form a common platform that scientists could easily work with. So we have a prototype ready for the community to work with. If you go to this URL, you get to the same page pictured here, and we have multiple scientific workflows represented as Jupyter notebooks. These Jupyter notebooks connected to high-performance computing resources available on advanced cyber infrastructure in the US. And also we have a catalog that organizes distributed geospatial data resources, and the Geospatial Data Science curriculum Eric will introduce you to also is getting integrated into this platform. And recognizing iGuide is a pretty significant investment from the National Science Foundation to enable this convergence research and education endeavor. But at the same time, some of the challenges were really tackling are bigger even than what iGuide could afford to address alone. So we're working with the broader community through our engagement and partnerships team that is really set up to sustain this multifaceted ongoing engagement campaign consisting of a virtual consulting office. We have partnered with UCGS to conduct several of those virtual consulting offices. And we have a partnership program and also a science communication program. The article you saw from the Directions magazine was prepared by our science communication program and team. So we have about 20 partners already working with us, and we would welcome more partners to join the force in the future. And the evaluation knowledge transfer team here is to help optimize iGuide through bi-directional knowledge transfer to industry and public sector stakeholders, as represented by the partners I mentioned, by leveraging partnerships to assess both transfer mechanisms and the degree to which iGuide's outcomes align with real world needs. This certainly includes, for instance, resources for curriculum development. So our evaluation knowledge transfer team has help from a council of geospatial leaders, a distinguished group of not only academic colleagues, but also industry colleagues and the service sectors as well. So we got advice from this group of folks addressing how we would work with the broader constituency in terms of increasing the impact zone of iGuide, but also benefit the broader community in terms of knowledge transfer. So education workforce development team here, as well as the Convergence Curriculum, I mean, that are really the focus of today's webinar. So this team is led, as I mentioned, by Eric Shook and Mohan Ramamurthy from UCAR. The objective is to create convergent learning resources and programs to promote knowledge and skill acquisition and build geospatial data science competencies for diverse learners. So this is going to be the very focus of the webinar, starting from a few slides later here. So I would not go into the details, and Eric has quite a bit of materials elaborating this structure and the framework. But I also want to quickly just emphasize it's not just Eric and myself here. We have a sizable team, as I mentioned earlier, on our Slack channel. To be exact, I think I counted it this morning, 105 members. This is a family picture we had from our first all-hands meeting last September in Chicago. That was quite a fun event. And now I turn this back to Eric to give us a deep dive into the Convergence Curriculum for Geospatial Data Science. Thanks very much, Eric. Let me do the control thing.
Yeah, well, thank you, Shaowen.
See if you could move anything.
We're let's see.
Are you good?
It does not appear for me to be able to move your, it says I can control your screen, but it doesn't do anything.
Okay. So let's
We'll have to swap.
Let's
For everyone listening, we tried one of the Zoom features to do a swap here, so that I could control the screen. We didn't have to do a screen switch, but
Well, while you're making that screen switch and just setting stuff up, Eric, just a quick reminder, everyone, you can feel free to put your questions in the Q&A. We will get to those after Eric goes through, but it looks like we're back on track, so have at it.
yeah, so yeah, I'm one of the co-leads for the wonderful education and workforce development team. So as Shaowen mentioned, I am presenting here, but certainly these are not all my work. And I just want to thank the wonderful team that we have in kind of doing this. To give a high-level perspective over what are we trying to achieve over the course of these 5 years for iGuide, the EWD, Education and Workforce Development group, really has 3 big tasks that we're working on. The first is really to understand, learn from, and forge connections with communities of practice. So, of course, the GI science community, UCGIS, is a project partner, and everyone here likely represents more the community of instructors and learners, early career professionals, and these sorts of things. We also have, Shaowen mentioned, a strong partners community out in industry, nonprofit, government, etc., as well as, for lack of a better term, an infrastructure community, the people who are providing, in the organizations that are providing data services, computational services, cyber infrastructure that really serves as an enabler for us to be able to do this type of science in order for people to kind of learn these sorts of skills and this sort of knowledge. And really what we're trying to do is merge all of these people, practices, organizations, so that it's not just an academic enterprise, and we're really trying to serve a bigger kind of need. So in short, that means we really, really want to hear from you. We've had several listening sessions. We hosted one virtually during AAG last year. You'll hear me talk about, at the end of the presentation, we actually are running an AAG workshop. I'll be at UCGIS at the symposium. I'm sure Shaowen will be as well. So what we're really looking for is pain points, what's working well, and how we can use this project as kind of a lever to move the field forward. And it's not just the GI science community, it's a number of other communities that we're working with, and we're trying to kind of merge these sorts of things. So feedback is absolutely essential, and you'll hear that a couple of times throughout this presentation. Another big task is to design connections to the iGuide platform that Shaowen talked about. And this is to support research-linked learning pathways. So the whole purpose of this is to get learners. Learners could be undergraduate students, graduate students, postdocs, current scholars, faculty, research staff, in trying to get them to better leverage some of these technologies in the platform in order to do better science, right? This is funded by National Science Foundation, so we're really trying to push a better way, and hopefully a more effective way, in order for people to improve their research process. And then the third task is innovative instructional and training activities for convergent science education. This is a slightly newer approach focused by National Science Foundation, is the idea of kind of convergent science. So we had interdisciplinary, we had transdisciplinary, and now the new push is for convergent science, where we're trying to take and honor the perspectives across the many disciplines and tackle these big, hairy, complex problems. And what we're trying to do with this convergence curriculum is trying to provide a flexible curriculum so that different science domains and different individuals can fill in knowledge gaps and skills gaps that they might have in order to contribute to one of those convergent problems. So that's kind of the motivation of what we're talking about today. So as Shaowen mentioned, we're one of 6 teams in education and workforce development. And really it's kind of our task to get all of these groups to actually converge on some of these problems on resilience and sustainability. Of course, within the project, this is a smaller task than trying to get a number of science communities to converge outside of the project. And so our role is to really help with the education in training to get people from a variety of disciplines: social science, environmental science, geographic information science, and geography, in order for them to kind of come together with their shared vocabulary, coming together with different skills, and being able to tackle a problem in a really useful and productive way. So what does that, kind of look like, or how do we envision this? Well, you can imagine, pulling a swath of scientists from a variety of different backgrounds and saying, we're going to tackle this problem. One of the major problems that iGuide's trying to tackle right now is aging infrastructure, and specifically aging dams. So if we're looking at the problem of aging dams, we want to be able to take a hydrologist, a social scientist, an economist, a GI scientist, and to have them come together as a group and provide their various perspectives on a huge problem, which is as these dams age and they're not always maintained in a way that we would hope, this can lead to things like dam failure. Which dams are very likely to fail, and which of those dams, if they failed, would have a huge impact. Of course, impact can be looked at lots of different ways. We can look at it from the ecology, we can look at it from the economics, we can look at it from human lives and health. We can look at it from a variety of different perspectives. So what we want to do is to be able to bring all of these people together from their various perspectives, have them converge on their problem. And as education workforce development, we want to be able to get them to have enough training and enough shared vocabulary to work together on that problem. And then after they've worked on that problem, they might diverge back out and work on other problems. So this isn't necessarily a permanent training where, the hydrologist then becomes an aging dam expert. Instead, we just want to be able to give them enough knowledge skills to work on the problem in a very effective collaborative way. And then perhaps they might expand out. Another kind of goal that we've developed as a project is really building in the open. This is a little bit driven more from, I would say, kind of what you see in the startup culture, the business culture, where perfection is the enemy of completion. I think as academics, we can all agree that sometimes many of us are perfectionists, and that leads to slower progress, and we're not willing to share things until they're absolutely perfect out in the community. And that can really hurt in terms of getting feedback as quickly as possible. So instead, our project is really kind of adopting a strategy of building out in the open. So as materials are ready for piloting and getting feedback, we're making them available so that we can get feedback early. We have, as part of the project, these VCOs, which stand for virtual consulting offices, and these serve as mechanisms for us to gather feedback from the community. We hosted one back in October, November of last year, and then we just hosted one last month for the Convergent Curriculum. And those have been absolutely wonderful. And we'll talk about some of the changes that we've actually made to the curriculum and the materials based off the feedback that we've been gathering. So what you're seeing today and what we're presenting is kind of what a startup might call a minimum viable product. So we are not complete. It is not finished yet, but this is enough material that can add instant value to your in-class and out-of-class activities. And what we're really hoping to do is start to get feedback in terms of what the community really needs to solve some of those pain points that you might have of introducing these newer topics. This isn't necessarily to replace the tried and true, spatial data models that have been taught in GIS classes for forever. Instead, it's meant a little bit more to introducing these newer topics like geospatial data science and GeoAI, where many people have less comfort, and the pedagogical practices and the labs and the materials haven't solidified yet. So this is one of the pain points that we're hoping to solve, at least in the GI science community. So back in September, October, we had our first rendition of the Convergence Curriculum for Geospatial Data Science. And it's pictured off on the right. You'll see that this picture looks a little bit different than the one that Shaowen showed earlier and the one that I'll show on the next slide. It had many more components, and we presented this to multiple communities and got feedback that it was a little bit repetitive and had some components that weren't necessary. So we've actually reduced the number of components and streamlined it based off of community feedback. And the whole idea of this curriculum is to support what we call multiple learner pathways. We should, through this curriculum material, support a hydrologist learning some geospatial information and things like geovisualization so that they can build up and can kind of contribute to convergent problem, just as much as a GI scientist should be able to learn something like ethics in geoethics, if that's maybe something of a weakness for them, or they don't have a lot of experience in those areas, or perhaps the area of computing, where maybe a traditionally trained GIS expert wouldn't have a significant amount of training in computing, and then build themselves up in terms of their competencies and their experiences so that they can contribute and be kind of an active participant in geospatial data science. So this is kind of the way that the curriculum is constructed, is to support these multiple learner pathways. And really what we want to do is structure it such that you build knowledge and skills and competencies that are really infused with these advanced technologies. So what we're trying to do is to get the platform to be an active component of the knowledge and skills building. And it should be kind of an enabler as you're learning so that you become comfortable using a lot of these technologies. Now, of course, GI scientists may not necessarily feel like this is a foreign concept to them because, we all kind of grew up, academically in our education and training, just using GIS as a tool in order to kind of enable our thinking and to help us solve problems. So this is kind of something that comes quite intuitively to us, but it's not necessarily true of all sciences. So when we're supporting multiple learner pathways, this is something that we have to be kind of explicit about when we're really trying to design all these pedagogical materials. The other core idea with this convergence curriculum is we wanted to move beyond the traditional 15-week course. We recognize that while, I'm in academia, so we have these 15-week courses. Right now I'm teaching principles of geocomputing at the University of Minnesota. But we also have this new idea that is really starting to gain traction of lifelong learning, on-demand learning, or micro-credentialing, where you have, sometimes it's just learners. It could be graduate students, it could be postdocs who just want to learn a little bit to enable them to do something productive for their own research. So a hydrologist might want to learn enough about geospatial and GIS in order to improve their hydrology research, right? You might have a GISer who wants to learn just enough in geospatial computing so that they can be a practical, competent programmer, but doesn't need to be a full-blown software engineer or an expert level programmer. So the idea of the curriculum is to go beyond designing, a series of 15-week courses and instead have it be a little bit more modular, a little bit more mix and match with what it is that we're doing. So based off of that feedback, what I want to show today is what we're calling the Convergence Curriculum for Geospatial Data Science version 1.0. So we had some pre-releases where we were gathering feedback, and we feel confident enough based off of feedback that this is our 1.0 version. Will this change? Most likely. We're hoping to be able to pilot it, gather more feedback, and hopefully really get to this solid, maybe 2.0, 3.0 version that is really kind of solving some of those pain points and moving the fields forward and for helping our communities of practice. So we continue to refine this based off of feedback. And what I want to do is just kind of walk through the curriculum as it's designed right now. Starting at the bottom, we have foundational knowledge threads. The idea of foundational knowledge threads is that we have these kind of components that sit by themselves, and everybody should understand a little bit of each of these components in order to be an effective person who is going to help tackle convergent problems. But these things can stand alone. So for example, you can learn about visualization without talking about analytics. You can learn about geospatial without understanding ethics. And each of these kind of foundational knowledge threads have their own ways of thinking. So we have geospatial and spatial thinking, we have computational thinking. They have their own way of working with data. They have their own sets of methodologies, and they have their own tools and cyber infrastructure, CI, that you tend to use when you're working in these spaces. If we move one model or one level up, we then have knowledge connections. And this is where we're taking these foundational knowledge threads and mixing and matching. So if we combine geospatial and computing, you get very inventively geospatial computing, which is the area that I tend to work in. But we can also combine geospatial with ethics, and we get into geoethics. Now, of course, you draw on the foundational knowledge threads, but geoethics has its own kind of advantages and disadvantages that you can talk about and learn about. So then we have these knowledge connections, and then we move up into knowledge frames. And this is where we're starting to really infuse that technology, which really kind of frames what it is that you're doing, the questions that you ask, the way that you work with the data, and starts to have this own kind of workflows and methodologies. So we work up from GeoAI into Geospatial Data Science, talking a little bit more and incorporating a little bit more of domain knowledge as we start migrating our way up. And at the very top, we have what's called knowledge convergence, where we're really working on those convergent problems, such as aging dams, where you really need multiple perspectives in order to contribute. And this is where we bring in all that domain knowledge, in addition to the geospatial data science and all of the kind of knowledge pieces that we're building throughout the curriculum framework. So that is the idea behind the convergence curriculum that we're presenting. And in lieu of having 15-week courses, what we've designed is a very modular structure. Now, I realize that this table is a little bit overwhelming. So for each of these components that you see, each of these boxes, ethics, geoethics, GeoAI, geospatial data science, what we aim to do is to develop 3 sentences that describe each of those components that any learner could look at and understand and be able to define that particular component in 30 seconds, right? So, sentence 1, give me a definition of that component. Sentence 2, give me a key idea behind that component. And sentence 3, give me an example. If you're looking at the pedagogy, this aligns with Bloom's taxonomy at kind of the remember level. And an example learning objective would be define GeoAI, right? This would be a learning objective that would align with the 3 sentences. This is a really, low level, easy way for people to get a broad brushstroke of the entire curriculum. You might go a little bit deeper, and maybe an instructor wants to insert 3 slides into an existing slideshow. This would take, maybe 3 minutes of a lecture, where perhaps in an advanced GIS class, you just want to introduce the concept of GeoAI. So an instructor might bring in these 3 slides that includes a definition, an example, and an active kind of question or discussion point to bring in an active learning component. And this kind of aligns with the understand. So here, a learning objective might be recognize one example of GeoAI that you discuss in class. So again, about 3 minutes, but this really helps with being able to mix and match and bring in, these topics into existing very packed curriculum. The next deeper level is the 3-hour module. And this is really where we start to get into the depths of it. This involves a 1-hour lecture. So this is kind of the standard lecture that, an instructor might include, but it also might include a boot camp or a summer school or a training like we're going to be doing at AAG, where you have, kind of a introductory material, and then a hands-on activity. So this is something where the learners actually get to engage with the concept for an hour, actually doing something. So it's not just talking, it'll be actually doing something. This is where we bring in the platform. where, students actually get to play with it, or, scholars, professionals, etc. To prep the lecture and the hands-on activity, you can have kind of a 1-hour reading and reflection. So just a couple of key readings to kind of prime the pump a little bit so that learners are ready to go. And then the next level deeper is a 3-week unit. So this is where you have some linearity and you can start to really build depth. So this is kind of the way that it's organized. Our first priority with the curriculum right now is focused on getting 3 sentences, 3 slides in a 3-hour module for every single curriculum component. And right now we're actually actively piloting some of the 3-hour modules and some of the 3-week units. So we're going to be providing some feedback and some materials based off of what we're actively piloting in some courses and some trainings. But again, with the model of kind of building in the open, we're hoping to get some early feedback from this before we really build on into those 3-week units. So the whole idea of this is so that we can have very efficient reuse. We're all very busy, and the idea is that we can efficiently reuse all of these materials. So the 3 sentences that everybody writes can be the perfect introduction for the 3 slides. The 3 slides are a great introduction for the 3-hour module because it gives you the definition, it gives you an example, and it gives you a discussion point to start off your lecture in an active learning style so that learners can be engaged right away and starting to think a little bit about the topic at hand. We can then combine 3-hour modules into a 3-week unit by building up a little bit more complex modules. The other idea that we have and that we're really striving for is to use existing what are called open educational resources. So those resources that people are already putting out there for free and out in the open, we are trying to leverage as best as possible. There's no sense in reinventing the wheel. There's a lot of great material out there. So I'll show you an example of us already using that for geovisualization, for example. So, we can take a quick look. If you go to iguide.illinois.edu/convergence curriculum for geospatial data science, I'll throw that link in the chat after I'm done so that you don't have to type it in right away. You can actually see and track where we're at right now. So if we scroll down, we see the model, the current curriculum model that we're on right now that I just showed everyone. And you can actually get all of the materials that we have ready to share thus far. So we have the foundational knowledge threads right here. We have the knowledge connections here. We have the knowledge frames here. We have domain knowledge, which includes urban studies at the moment, and then knowledge convergence with aging dams. We also are collecting community contributions either through our community champions through iGuide, which includes food security, urban heat island mitigation, as well as other community contributions such as reproducibility. A huge shout out to Joe Holler and Peter Kedron, who have been contributing some materials in the area of reproducibility, which aligns very well with the curriculum that we have. So if we click on one of these, let's say geovisualization, you can see that we have our 3-sentence overview of the particular topic. We scroll down and you can see that we have 3 slides that talk about geovisualization, give an example of it. And then we scroll down even further and we have a 3-hour module, which includes learning objectives, gives readings. And what we'll find is that, oh, I don't have the slides right here. We have the slides on a deck that are pointed to already existing open educational resources. I forgot to update the Google Doc that this one's pointed to. We have a dev copy that I didn't move over to our production one. And this is actually using existing materials. Here we have the UCGIS body of knowledge are one of the key reading materials that we're trying to use in the curriculum because the body of knowledge is a fantastic resource that's already out in the open and is actively being developed by UCGIS. And then all of the slides and the hands-on activities are actually modules that have already been produced for geovisualization, which is fantastic. So feel free to take a look. We welcome any feedback. We're actively looking for feedback. The idea with the curriculum materials is that everything in batteries are included, which includes lecture notes. So one of the things that we've really tried to emphasize is making this so that we can support multiple learner pathways. So that means that people may not have the background expertise in each of these areas. So we're asking people who are contributing to these components to give, what would you say on this slide, or what are the key points that somebody should point out? And if you click on the little 3 buttons, you can click open speaker notes and you can actually get the lecture notes, or if you download it, you get the lecture notes that comes along for the ride. The other aspect of this, and this is something that we're working on very actively right now, is that you get the platform already included. So all of those hands-on activities that we're talking about, learners and the instructors should be able to just click a button and it will launch those hands-on activities on the iGuide platform so that you don't have to support software, you don't have to support the data, you don't have to make sure that your GIS labs are all re-imaged with a new something. And then we've all ran into the problem with library dependencies and software issues and everything else. So instead, what we're going to be doing is hosting it over the web so that everything's ready to go. And a lot of it is going to be using Jupyter notebooks, which are used by, thousands and thousands of data scientists around the world. So we'll have lessons written in Jupyter notebooks that are launchable by everybody. One of the notebooks that we're bringing into the platform right now is another project that I'm leading called the Hour of Cyber Infrastructure, where we have a number of hour-long hands-on lessons already. So we're actually moving all of those lessons from that project over to iGuide, because it aligns with this project quite considerably, because the Hour of CI lessons are designed to help build cyber literacy for GI science. They're also built as open educational resources. So a lot of the 1 hour hands-on activities will be kind of fed from this Hour of CI project, which is available at hourofci.org. What is a good example learning pathway? This is an active question that we tend to get when we're listening to our communities of practice. One that we're going to be actually demoing at AAG is, a geographer or a GI scientist trying to learn the basics of geospatial data science, right? In a workshop setting where maybe you have a half-day training. A reasonable pathway that we would anticipate would be that this person or these learners would already have expertise in geovisualization, geospatial data and spatial thinking, a lot of analytics. So you've already had, experience with geospatial analytics. However, GISers and geographers tend to be a little bit weaker on the computing and geospatial computing side. As well as kind of the ethics and geoethics. This is something that we're starting to change in the curriculum and a lot of GI science programs. But if you're an existing GISer, these might be kind of 2 areas where you might need a little bit more development. So a training where you're trying to bring up somebody in GIS or geography into geospatial data science, you might have to bolster those 2 areas. So a training that we're planning on focusing on would help people understand and appreciate ethics and geoethics, and then also build up their computing and geospatial computing knowledge and skills so that we can get them to a level where they can start looking at GeoAI and then geospatial data science. And that, kind of assumes that they already understand data mining, geovisualization, and geospatial analytics, which tends to be a strength for a lot of GISers. So this is just one example. Now, if you use a social scientist, they might have, a completely different skills background. So it might have a different pathway in terms of what you're really trying to emphasize. So real quickly, and then I want to open it up for questions. Moving forward, where are we going to be doing this? Where can you look for us? We are hosting the first iGuide Summer Institute in Boulder, Colorado. It's going to be from August 6th to August 11th. We're going to be having a lot of healthy fun. This picture is from the last UCGIS Summer Institute at University of Illinois. They had a farmer's market outside, so we were eating fresh fruits, or fresh vegetables mostly. So that's yours truly here eating a carrot while we were working with all of the learners. It was a phenomenal experience then, and I'm sure it's going to be a phenomenal experience in Boulder. So if you have any early career scholars, students, please have them save the date. The applications are available. We're also hosting an AAG workshop. So we welcome students and scholars to sign up. The title is Professional Development for Current and Future Geospatial Data Scientists. It's going to be on the 25th from 9 till noon. So this is where you get to actively engage with the curriculum materials that I just talked about. And with that, I want to actually see if there's any questions for us. Remember, our first task is to really listen, to get feedback from everyone. Of course, we want to acknowledge the National Science Foundation, all the support that we've gotten from our teams and our contributors. And we really want to thank you for your attention and time today, because I know everybody's busy.
Yeah, definitely thanks to you both for the wonderful overview. And now is certainly the time. If you have a question, pop it in to the Q&A there. We would love to have your questions and hear what you're thinking and what you're pondering after listening to this set of really deep information. As questions kind of pop in, maybe I'll pose it to you, Eric, since you're currently on the horn here. What's, if you had like a quick initial finding or initial kind of discovery in putting together these pathways, these knowledge pathways, what would you kind of share offhand as kind of the first thing that's really stood out to you as you've been developing these?
Oh, that's a fantastic question for us. So I deleted a slide that actually helps with that. And the big thing that we're trying to get from everyone is, what level are we really interested in? The beginner level is something that is an easy target, but oftentimes what gets forgotten about is maybe the intermediate levels, where you're trying to, you already have a base set of knowledge, but you want to kind of get to that next level. That has been something that has really kind of gotten us a little bit, because if we scroll back to the curriculum, I was hoping to be able to share a 3-week module on GeoAI from my advanced geospatial computing course, where I redesigned it to align with this curriculum. We had a number of assumptions built into that class because it already kind of followed a principles of geocomputing class that I had taught that we hadn't built into the curriculum. So I'm actually working through, the dependency chains that we always, kind of struggle with as instructors and kind of educators. So I think that that's really a current struggle where we're trying to gather feedback from everyone as at what competency level, beginner, intermediate, advanced, is everyone looking for information? And, I assume at different components, we're going to have different wants and needs.
I think that leveling and figuring out it's the level of the pathway is almost as complex as the pathway itself. And so it's really interesting as we're kind of thinking about this, how do you work with these different places that people might find themselves and even addressing or feeling comfortable stepping into these spaces. So it's obviously a big step and why it's such a big project, I think.
Yeah, well, and I think sometimes, and feel free to interrupt me if there's other questions. I think sometimes this is also kind of the battle that you get between education and workforce development. Education, we tend to think, people are coming in with few skills and knowledge, and that's why they're being educated. Whereas workforce development is a little bit more already working with current working professionals, right? So It's not so true if you're talking about grad student education and things like that, but I do think that you get this kind of tug of war going a little bit where it's easy for an educator like me to go straight to the beginner level, but that might be missing some more intermediate or advanced needs that we have.
Yeah, absolutely. So wonderful question, kind of thinking about these pathways. In addition to Geo AI, which we can see up there, what about non-Geo AI approaches for convergence geospatial curriculum? And thanks to Shilong Shah for that question.
Yeah, that's a fantastic question. We've had some discussions within the team, and I want to say our first listening session with geographers, I want to say actually kind of honed in on this of saying, why is it that you have to route through Geo AI and geospatial data science to get to convergent problems? And my answer is kind of twofold. And then I'll let Shaowen jump in because he might have, a different kind of broader project perspective or just a different perspective in general. And one of the motivations for the curriculum is to narrow it down so that it's actually achievable. And one of the key contributions that we feel like we can make is having one pathway through geospatial data science. This is kind of an enabler that allows us to tackle convergent problems in a different way than if you were to route it straight through, let's say, a social science-based methodology. So this is something that we feel like can be a strength, kind of coming out of the GI science tradition here. So I think you can get to convergent problems. I mean, for sure, you can get to convergent problems without geospatial data science, which is why in the curriculum model, you see that kind of route from domain knowledge straight up. But we feel like for this project, geospatial data science gives convergent problems that we're trying to tackle this kind of like unique push and this kind of strength that we wouldn't have otherwise. So yeah, I think in general, you can tackle these convergent problems without it. But what we're saying is that with it, you can tackle it in a more powerful or slightly different way. So we are trying to get people up to that level so that you can at least kind of contribute in that form. But I'll leave it open to Shaowen to jump in here.
Yeah, thanks, Shilong, for asking that important question. And I agree with Eric. I think our primary focus here is on geospatial data science. What Shilong was asking is Geo AI versus non-Geo AI. I think in our current framework, we do take into account both, although Geo AI is perhaps taking quite a bit of our attention, but we certainly also address non-Geo AI. So we consider Geo AI is intersecting but not overlapping with the geospatial data science. So geospatial data science has an inclusive angle of Geo AI, but also includes other elements that are non-Geo AI. So if you look at the framework and diagram Eric has shown on multiple slides, the geospatial data science is our highest level connecting element to convergent problems, and below that is the Geo AI. And that Geo AI is not completely overlapping with the geospatial data science. Hope that answered the question.
Yeah, I think that's a great discussion and a great way to kind of dive into some of the frameworks here in kind of considering this really interesting and complex network of knowledge, skills, and practices, as I was trained to say by my doctoral advisor, Sarah. So I have to say it whenever I can. There's a question in the chat about the workshop at the AAG. Eric is already showing off that information. So thank you, Eric. Eric, you want to speak a little bit about is registration required? Is that open? How do people get into this if they're interested?
Yeah, so this is this workshop is actually part of AAG's professional development series. So through AAG, you should be able to register for this workshop through their regular kind of workshop mechanisms. We actually are not running the show on this one. We're part of their kind of bigger series, which is fantastic. So if you go to AAG workshops, you should be able to register your name and join us for a wonderful half-day workshop where it'll be kind of a mix of what we've kind of talked about here of, you know, some knowledge, some skills, some practices, to take Forrest three words. So you should be able to get some, you know, hands-on opportunities, and we'll be able to kind of play with some of the technologies and things like that.
Absolutely. And that's a
fun
great
time.
place to lead us into whatever you have next coming up on your calendars. So something to look forward to UCGIS as well. Eric, Shaowen, thank you both so much for your presentation today. We have been recording this presentation. It'll be up on the UCGIS website in some form in some time in the future. Thank you all for being here, and everyone have a wonderful rest of their day.
Thanks very much, Forrest and Eric.
Yeah, thank you, everyone.
Thanks all for participating.
Absolutely. Thanks, everybody.